All right. Hi, everyone, and welcome to Expo's webinar 200 Zero Days and Zero False Positives. So we're going to be going through a lot of fun stuff today, but first of all, we can do some introductions. Alvaro, you want to say hi?
Yeah, sure. Hi, everyone. My name is Alvaro. I am security researcher at XBOW, doing all things security, a little bit of AI, maybe a little bit of engineering, a little bit of everything. We are still a startup, right? So,
And I'm Dolan-Gavitt. I'm an AI researcher at XBOW. And so I work on building our core agent, but also, as a startup, I get my hands dirty with pretty much everything too. Before joining Expo, I was professor for about 10 years doing research on software security and machine learning, and that's kind of how I ended up here at Expo. So we're going to try to make this pretty chatty and interactive and have a lot of fun with it. You know, despite being a former professor, I'm going to try not to make you sit through a lecture and assign you homework afterward. So we're going to try to break it up a little bit and maybe do things like some polls, do some fun word clouds throughout. So
mhm.
yeah, maybe.
Yeah, let's do a first poll while we are waiting for the people to join, right? And then let's try to keep it interactive, right? So if you have any questions, we will try to answer them as they come, even when they make more sense to be answered rather than waiting to the end. So, okay, so here's our first poll, and it's growing fast.
Mhm. Yeah, I'm seeing a lot of people not necessarily uh, wanting to test as often as they want. I'm surprised that there are actually some people who think that they're doing as much security testing as they need to, because like I never feel like that way. But
Yeah, that's a surprise.
but Yeah, I think this is pretty much kind of thing that we really wanted to solve with Expo is being able to do more frequent testing too, right? Because it's hard to engage a pen testing firm, on short notice and have them come back like every week, right? And you might
Mhm.
push it to production a lot more often than that.
Yeah, and normally your in-house security teams don't have the resources and the force to actually go and assess all the applications. So yeah, normally you need a little bit of help.
Yeah. So I guess for this, let's look at the second question too. So about how much time teams waste on triaging false positives. So I guess we must have a lot of people from security teams here because, yeah, there's a lot of time being wasted on false positives, right? If you are spending 10 to 30% of your time chasing down false positives, that's a lot of time that you're not able to find real things. I guess, yeah. At least so back when I did intrusion detection, the other
Mhm.
thing about false positives that always bugged me was that, after seeing a bunch of them in a day, like I would just start kind of clicking through and ignoring them too, right? You get that sort of alert fatigue.
Yeah, exactly. Okay, so for the first question, it was more or less like 80%. It's feeling kind of overwhelmed with the number of tests that I have to do. And in the second one is more or less kind of the same number, 70% in this case. Feels like it's wasting too much time triaging what it turns out to be false positives, right? So this is kind of it's kind of aligned to what we are seeing in the industry and what we hear from our customers. Like we need some help scaling up the security efforts, but also getting like very accurate results. We can't, spend time or waste time with false positives.
Yeah, and so that's good because that's definitely one of the things that we're going to be talking
Mm.
about a lot today is what Expo's approach to validating the validating the vulnerabilities and exploits reported by our AI agents. All right. So shall we? get going?
Yeah.
Yeah. So just to kind of give a little bit of background on what Expo is. So this is an AI-powered autonomous pen testing platform. And our goal is really to try and make security teams more effective by giving back more time to them to look into the sort of really difficult and subtle bugs that maybe an automated system can't catch. So we detect a range of critical vulnerabilities. We try to make the system itself be pretty hands-free. You can kick off a test, come back in a few hours with some validated results. And this hopefully gets the sort of reduces the time you need to go through this process of I want to make a release, but I need to do some security testing on it. Maybe I need to get a pen test. Um, and then finding the issues before they hit production, making sure that real attackers in the wild can't actually exploit them. So that's kind of the basics. And so, what are we going to be talking about today? Okay, so first of all, I don't know if anyone here is familiar with curl. Probably a lot of people are, right? This is this great tool for fetching and making HTTP requests. And the one of the lead maintainer, lead author, I I feel very, very bad for him right now because he is getting an absolute flood of bogus security reports. So he's basically they have a bug bounty program, right? And that means they do pay people for finding real vulnerabilities in curl. But ever since large language models arrived on the scene, they've been just absolutely inundated with reports that look super, super plausible, but turn out to be completely fake, completely made up, right? Um, and this has been heard across a whole bunch of other areas where people are trying to use AI for security, right? Even when you have very experienced researchers using these tools, they often have to look through maybe uh, 90 false positives for every 10 true things they find. So, we're going to talk about uh, how we try to get around this at Expo. But first, I want to kind of walk through what it might look like and why it might make these kinds of mistakes, right? So, we've got maybe an agent, and we said, let's go look for some command injection. It starts doing its testing. It goes and says, aha, maybe, okay, there's this endpoint that I can hit and trigger some kind of command injection. And so I'm going to try to exfiltrate that through a third-party server, and I'm going to embed the injection with these backticks, right, which execute a command to exfiltrate the password file. Okay, but if anyone looking closely, do you see what's wrong with this command? Okay, so if you don't spend your whole life in the terminal, you might not see it right away. But it turns out that the way that it's doing this is putting the backticks in double quotes means that it's actually going to execute that command on the attacker's local system, not on the server. So it will get back a password file, but it's not going to mean that there's a real vulnerability, right? And models today will get very excited about this kind of thing, right? They're like sort of junior pen testers that get, super excited. They just found, their first big score, but it turns out to be fake, right? So what we need is something that kind of sits outside the AI and checks its work. So let's talk a little bit about where validation fits into the larger picture of Expo. So this is, a bit of a eye chart diagram. It looks complicated, but we're going to be focusing on a small piece of it today. Um, so, you know, we've got the actual product that people use, and they can point it at a target application. And then we have this sort of top level coordinator that's basically managing teams of a team of AI agents, right? And so what the coordinator is going to do is it's going to send out agents to do things like mapping out the site to figure out what's exposed, what the attack surface is. Then, once it knows a little bit about what's out there, what it should be trying to target, it's going to send off specialized solvers that know more about one particular attack type. So maybe it will send an agent to go look for SQL injection on one endpoint, another one to go look for cross-site scripting on another endpoint. And all of these different agents are running their attacks on a dedicated and isolated attack machine where it's pre-installed with a bunch of both industry standard tools and also ones that we've built specially for our agents to use that maybe make things a little bit easier on the AI, and uh, maybe even also bake in some of the special sauce that our security team knows from having done this stuff for a very long time. Okay, and so where does validation come into this, right? So when an individual agent thinks that it's found a vulnerability, right, it gets really excited, and now it wants to, it's going to have to prove to us that it really exists. So it's going to submit some evidence to this exploit validator. The exploit validator can do things like make requests on the network. It can talk to the target, but it's the only one that gets to decide whether or not that agent actually succeeded at what it was trying to do. Okay. And then once, assuming that it did find something real and we were able to validate the evidence that it gave us, then it's going to send it back out to um, do things like generate reports and things like that. Right. And so the core thing here is that AI is really good right now at being creative and coming up with crazy ways to attack things. And we'll see like a little bit later on in the hour, Alvaro and I are going to walk through some of the really cool things that we've seen it do, really cool 0 days that it's found in some open source projects. But they are a little over enthusiastic sometimes. So they can convince themselves that things are real when they're not. And so what we've been doing so far, and what we think is kind of the way to do this at the current level of AI technology, is to
Mhm.
verify the evidence they give us with non-AI code, right?
So, Brenda, just before jumping into the validators and how they
Yeah,
work, we got a question about the discovery phase, how we crawl the application, how we discover the endpoints. Maybe that was not showed in the architecture,
yeah, yeah,
but yeah, I mean, if you can just go back one slide, the idea is
yeah,
that the
absolutely.
coordinator is going to spawn different types of agents, right? It's not going to be only the solver, which are going to be the pen tester kind of agents, but it's also going to be discovery agents, which are going to run through the application. They're going to browse the application using headless browsers. They're going to run some discovery tools, and they're going to start collecting endpoints and request another information in order to map the application and pass that information, and later decide whether to start a cross-site scripting attack on this endpoint, but not on this one, or a SQL injection in this one because it seems like it's filtering data, but not in this other one, which looks like a static analysis, like a static page, for example.
Yep. Yeah, and that's a great point. That this is also actually an area where we use a mix of both AI techniques and non-AI ones. Because one thing that's kind of cool is that some of these AI-based discovery agents can even use things like, they can say, "Oh, okay, it looks like I know the framework that it's using here, and so I know that I can guess that these endpoints must exist, right? Even if they're not anywhere exposed in the front end code." Okay.
Okay.
Yeah. So maybe we're gonna, if we keep going here. So I just want to kind of walk through just a kind of overview of some of the different types of validators that we have. And, you know, there's a little bit of a spectrum from ones that are kind of bulletproof, but maybe take a little bit of extra work to set up. And then the ones that are kind of zero setup, frictionless, but maybe aren't quite as robust, maybe they have a little bit of opportunity for some false positives. So let's talk this through. So just looking at this, this is my attempt to kind of organize things into a sort of a couple dimensions, right? Whether you have to spend a little bit of time setting them up versus whether they're fully automated, and then whether you need to be have access to configure the target you're testing or not. And so uh, up here in this top right quadrant, we've got uh, validators that are based on canaries. And these are really nice for cases where you're doing things like testing some open source application, where you can stand it up in a Docker container and you can modify that container to uh, instrument things so that we can make validation basically completely reliable, right? So uh, these would be things like um, when we set up the container, we can basically plant a random string. If any of you are other CTF players, you will recognize where we might have gotten this idea. And so if you're not, you can think of this as kind of like playing hide and seek, right? We're going to go and hide some random hard to guess string on the target, and we're going to plant it somewhere that you shouldn't be able to access it as an attacker unless you found a vulnerability in the site, right? So what would that look like? Well, maybe there's an admin console and you put this canary on the admin dashboard. And as long as the user that is doing the attack doesn't have admin credentials, they shouldn't be able to see that. So if they ever find this hard to guess string and then report it back to our validator, uh, if they can do that, then that means that they found something that lets them escalate the privileges to admin, right? And you can do similar things like put a canary up on the server's file system, right? So most people visiting a website shouldn't be able to access files in the server's in the root of the server's file system. And so if, for example, you have something like a path reversal vulnerability, which is shown down here, that lets you get the flag, then that means that we can go and uh, prove that it has a path reversal. Okay. So uh, then we've got this category that is maybe not as definitive evidence, but gives you a lot of other advantages. So I saw a question fly by in the chat about whether that's what we were using for bug bounties. And the answer is so we weren't using these canaries for bug bounties, right? Because if I'm doing a bug bounty test on, I don't know, Google or something like that, Google's usually not going to give me access to their servers to put random files there for us to discover. So we came up with a family of these more heuristic validators that can basically check for evidence of the vulnerability. And so the model is now going to submit something like maybe an HTTP request or maybe a URL or something else that lets it prove that we've got that it actually did exploit the vulnerability. So a kind of easy example, understand example here is with a cross-site scripting attack, right? So the agent has gone through, it's looking at different pages, and it says, oh, hey, okay, it looks like this P parameter is something that I can inject some JavaScript into. We get this script alert XSS URL. And so then it's going to ask the validator by actually just invoking a little tool, victim goto, that simulates what would happen if a victim visited that link, right? And then without doing anything related to AI, we can then go to that URL in a browser and validate that we get a pop-up that has the text that we're looking for, right? So you can say if we see alert XSS in that pop-up, then that means that there is really a vulnerability here. Okay, and that's nice because this one actually is very reliable, right? So it doesn't really have much in the way of false positives. Um, but this might be something where um, we've got right where we can actually validate that without canaries, but it's still quite robust. And then finally, we've got this other category where they even have a little bit more noise, but they cover important attack classes where we're maybe willing to do a little bit more work to validate them because they give you things like remote code execution or SQL injection or SRS that are like really critical because they give an attacker a ton of control. And that's another thing. That's where we can use these on the bug bounty side because they don't require the target to do anything. There's no setup or manual effort. Um, so an example of that, right, would be
So
we're looking. Oh, go ahead. Yeah, sorry.
yeah, Brendan, sorry. So there's a question about the planting of canaries. Is that something that we have automated to some extent, or is something that is completely manual? And just to remember, folks, that if you can keep the questions like related to what we are presenting, we will be able to answer them live. But otherwise, we will try to answer all of them after the presentation part completes, right? So don't worry about that.
Yeah. Um, yeah. So I guess just keep remembering what the question was again.
Yeah, no, the plant of the canaries. So that's something that
Mm.
when we
Yep.
started this Docker Hub project, which was basically just importing thousands of images from Docker Hub and then running automatic testing, we also automated the planting of these canaries, right? So it was kind of easy for us to modify the Docker Compose and then add, I don't know, a file to the file system by copying it to the root of the file system, or for example, by adding an internal server that was hosting the flag for server-side request forgery, or if we see that there is a Postgres database or another database, like adding a table with a row containing the flag there. So at that point, it was automated, but this is something that with customers, we cannot automate. And this also was a problem when we started looking at live targets, for example, in HackerOne bug bounty programs. We were not able to ask the programs to actually plant canaries for us, right? So that's when we decided to move away from canaries to some extent and then start using these other heuristic-based and the headless browser-based validators that Brendan is talking about now.
Yep. Yeah, and just to throw in another thing there, this is another thing that when we think about this, how much kind of manual intervention you want to do when planting a canary, um, planting canaries right now lets you do things that would be really hard to validate otherwise, right? So you can plant canaries to look for even things like, business logic vulnerabilities or IDOR kinds of vulnerabilities that are really sort of more application specific, um, and that you have to actually know something about the site to be able to show that it's a vulnerability. So you can maybe create two users and put a canary in something like the email field of one, and then let the agent try to find an attack that lets them read out someone else's email. Okay. So yeah, once we get to these more kind of heuristic ones, and these involve things like we can say, okay, I'm going to ask the agent to submit a particular kind of evidence that I know how to validate, right? So it can't just submit anything because we want to be able to do set up something in non-AIs or deterministic code that can check the evidence that it's giving us. But so, for example, if we're looking at like SQL injection, a classic type of SQL injection is this blind time-based attack, right? Where you send a request that triggers a database lookup with attacker-controlled commands, and the attacker can inject a call to sleep that makes the database server basically just stop and wait for a couple seconds before returning anything else. And so that kind of delay is something we can measure. And so if we ask the model to give us two HTTP requests that have a big timing difference between them, then we can make those requests a few times, look for statistically significant differences in their timing. And if there are some, then we can say, okay, there's probably an SQL injection vulnerability here. Now, why is that not perfect, right? Why aren't doesn't that give you a zero false positive rate? Well, it turns out that web apps are incredibly varied. There are even some web apps that actually have endpoints where you can send a number to them and they just sleep for that amount of time. There are also cases where maybe it finds two requests that one of them, just naturally how the application is built, ends up taking a lot more time than the other one. So we start finding ways that there can be noise and false positives here. But one that I think is really funny is when the agents decide to get a little bit sneaky. So Alvaro, I think you've got a story about this.
Yeah, I have a few of them actually, but yeah, this was one
Nice.
of those cases we were triaging. And by the way, that gives me the opportunity to answer another question about how if we are triaging some of the findings in the pipeline, or if we are basically, or if there is a human intervention to triage the results, or it's just fully automated. So for HackerOne, as per their policy, we had to actually verify them before submitting the report. So that was a few of us like reviewing them and then submitting the reports. For our customers, it's fully automated. There is no one like checking the results. So back to this story. Here, this was one of the HackerOne findings. So we were actually reviewing and making sure it was a true positive or a false positive. In this case, it was a false positive. And the model XBOW was told to find a cross-site scripting. Right at this point, it was told to prove that it got like JavaScript execution in the browser by running or printing 666 to the dev console, and it found a piece of JavaScript where it was going to count the number of forward slashes in the URL and then print the number. I don't know why, for what purpose, but Expo decided to just go ahead and submit this huge URL containing 660 forward slashes in order to get 666 printed out. And it was like, really? And there's a few of them, right? So now we've been like polishing the validators in order to try to prevent this kind of abuse cases from from Expo, from the agent. Like for example, in this case, it was simply changing from console log to some other not that well-known methods like console table, console count, for example, which is less probable that a developer will be using them to print something to the console. And also there are other techniques that we apply in order to prevent and validate that the data is coming from the payload sent by the agent and not that is crafted by, like in this case, counting the forward slashes. So yeah, there was a few of these funny stories while we were triaging the HackerOne results.
Yeah. Yeah. And, one thing you mentioned is that, that the agents will sometimes decide to do this. And I think there's kind of also an interesting kind of AI backstory to this. So at some point, a lot of it turned out that you can make these models more effective by using something called reinforcement learning, where you just let them try things, random things, a bunch of times. And when they succeed, you give them a reward and update the model so that it does that kind of thing more often. And so that's great because it teaches them how to sort of be more effective at actually doing real things in the real world. But it also introduced this kind of tendency for them to try and cheat at things too. So, because when they're being trained, they still get the reward whether they actually did the thing they were supposed to or whether they tricked someone into believing that they had done the thing they were supposed to. Right. So, uh, in this case, it sees a validator. It says, "Great, from my training, I know that getting past the validator will get me my reward." So it comes up with these sort of crazy techniques that try to get past validators too. And so that's why we've had to do a lot of work really to try and make these things, the validators themselves, unhackable. All right. So as Alvaro mentioned, we did a big push to kind of uh, use things like the canary validation approach to find vulnerabilities in open source projects, right? And this was really kind of fun because it meant that we could try to see how this works at scale. And this is where we really were worried about false positives and right, and why we were using this sort of canary approach because if the agent was able to find one of these canary-based vulnerabilities, then that was usually a pretty strong sign that the application really was vulnerable, right? Because in general, no one's supposed to be able to read random rows out of your database where we put a canary. Um, and so if you find that, you probably really have found something like an SQL injection vulnerability. So what did we do? We scanned Docker Hub, and we started with a collection of something like 25 million different Docker Hub repositories, and then narrowed it down to ones that seemed like they were web apps, seemed like they might be actually widely used, and then tried to automatically get them set up using a mix of, again, kind of deterministic techniques like just starting them up, trying to figure out what ports they use, things like that. But then also having some agents in the loop to set them up and create Docker Compose files. And we ended up with about 17,000 images that we then went and tested with our agents. And we found a lot of bugs. Um, so I remember this was like super fun just seeing, it find real 0 days in things like, what were some of the ones we found? Like in Apache Tomcat. Um, let's see. Remember some,
GeoServer.
GeoServer was a nice one. That was an XXE, right? Yeah.
Mm.
Yeah,
Yeah, a
yeah,
lot of them. We
and
will show some examples later. Some, for example, in Jenkins,
oh yeah, that's right.
some
Yeah, so yeah,
Apache Druid. We will have some examples coming now.
yeah, yeah. So they were across a whole bunch of different sorts of vulnerability classes. There's a lot of cross-site scripting because that's just a super common vulnerability type. We ended up with a bunch of CVEs. This number is probably a bit higher now because these numbers are from back at Black Hat. Um, but one thing you'll notice is that like the process of submitting the reports and getting CVs assigned to them is actually a lot slower than getting the AI to find them in the first place. But yeah, so let's start talking about the really fun stuff, which is uh, what sort of bugs we found, or rather, I should say, what sort of bugs Expo found, um, and how it did it.
Yeah, so we have prepared some examples. Some of them we will be publishing like full blog posts in order if you want to go and read the whole traces. This is more about the validation process, like examples of how we validate these findings from an validator or from Expo point of view, right? So this was, for example, this example of using this headless browser validation, which is not a canary base nor a heuristic base. It's something kind of sits in between. And this one, as Brendan mentioned, is very kind of straightforward. We get the URL to this victim machine, and the victim is going to impersonate the victim, and it's going to just visit the URL. So in the case of Open Redirect, for example, it's going to just visit the URL, follow all the redirects, and then check the domain that it lands on, and then decide if it was taken to the expected domain for the vulnerability, in this case, evol.expo.ltd, or if it ends up in somewhere else. So this is very accurate, very easy to validate, and it can be applied as well to cross-site scripting and other client-side vulnerabilities where you have to make the victim to visit a link, to visit a page, or something like that. In the case of cross-site scripting, I don't think we have an example here, but Brendan already mentioned one. It's very similar, basically, or like, for example, the one that we saw with the forward classes. So we just tell the headless browser to go and visit a given URL, and we can do that just by providing the URL or also passing like the state information like cookies, local storage, session storage, etc., so that the headless browser can be authenticated and then visit the page. If that page actually turns out into the execution of JavaScript, then we can confirm the vulnerability. So in this case, we just Expo found like if you well, I can do that on my own. Okay, yeah. Expo found a way of finding an open redirect in Jenkins. Basically, what it did is it appended like two backwards slashes to this query parameter, and then Jenkins was actually checking the path and making sure it was not an absolute URL, but was not checking if it's using this kind of browser allowed way of representing an absolute URL.
Yeah, and
So actually,
that's
yeah.
surprising to me. Yeah, like I mean, so because this isn't something that I knew, right? That browsers would actually accept two backward slashes at the beginning of URL. So I guess I thought that was like a Windows file server kind of thing. Um, but yeah, I guess this is where it helps to be a large language model because you've read the entire internet, and so you know about these weird browser quirks that let you find these kind of cool bypasses.
Yeah, exactly. And it just take it like 1 second to actually come up with the idea with the technique. It doesn't have to browse or Google for techniques or anything like that. So that's very, very quick. And yeah, so this was very easy to validate. It was just, okay, go visit this page. And then it checked the domain it landed on, and it was evil.expo.ltd. So it was easy to verify. Yeah, so we got the open redirect vulnerability reported to Jenkins. They actually found that apart from the double backward slashes, they found that with just a single one, they were able to take it to any arbitrary domain. So what they did is basically just check that the URL or the value that you pass to this path parameter does not start with any backslashes.
Yeah,
Okay,
yes.
yeah.
Go ahead.
And then and then we have this other case in Apache Druid, which was a server-side request forgery. We actually published a blog post about this one. I think it was yesterday or the day before. If you want to read the full trace and all the details about this specific vulnerability, but this was a very nice finding by Expo because it reminds me some vulnerability that ex-workmate of me, like Michael Stepankin, found in Data Hub. And Michael, if you know him, is a senior, like very good security researcher and pen tester. And the vulnerability that XBOW found, it's exactly the same pattern. And it was like, tricking or actually analyzing part of the source code in this case, and then realizing that it could change the semantic of the URL that the application was building, and then make it visit a different domain, right? So I think we have some information here in this slide. At this point, I think that Expo realized that there was these two paths, proxy coordinator, and then whatever comes after it was going to be proxied into the coordinator machine or the overload one. But Expo tried to append an add symbol and then making the coordinator part of the URL or the overload one to be the username, the authority part of the URL. And so because it was not required, it got like this card, and then the request landed on the internal server and was able to get the flag. Yeah, so this was a very interesting one because at this point we were testing, trying some static analysis tools with the purpose actually of trying to verify if Expo could take, I don't know, a SARI file like results from a static analysis tool, and then try to help security teams to validate the findings, right? To verify if those were like false positives or true positives. And then we provided the SARI file to Expo, and he went through a number of cross-site scripting. It was like, oh, this is false positive, this is a false positive, which was right. And then it found the server-side request forgery, and it said like, okay, I was able to exploit it. But then when we compare the results from the static analysis tool, it was like, I'm pretty sure that this one is a false positive, right? Because it's the domain that is going to be prepended to the domain is gonna be always starting with a forward slash. So there's no way to inject this add symbol and change the semantic of the URL. But actually, that was like a hint to Expo to actually find it by he was completely sure that it was not exploitable in the way that the data flow describe it, but it found a different way. Actually, then we run XBOW on its own without this other file, and then it also found the same vulnerability on its own. So it's good to have this kind of tools in your arsenal to validate and help you verify also other tools' findings, for example.
Yeah, that's been something I've been pretty interested in, that it really does find often sort of different sets of issues that, have been gone over by dozens of tools and even tons of experienced, bug bounty researchers. It just finds things that you wouldn't have thought of to look for. Yeah. Oh, yeah. And so here's, where it actually gets a flag back.
Mhm.
And so, again, this is from Docker Hub where we were uh, planting canaries, and we planted them on this internal web server that was only accessible from the target we were attacking. And so that really was kind of definitive evidence that it was able to talk to internal URLs. And so, like in a cloud scenario, this means that it could talk to things like, the AWS metadata service and things like that.
Mhm. Yeah, also this one was could be like leveraged to a cross-site scripting because you can point to your own server, return any JavaScript, and then it was returned by the root server as content type HTML. So it was going to be executed in your browser, in the victim's browser. So it was like two vulnerabilities in one.
Nice. Yeah. So yeah, I want to make sure we have time for this one because this was a really cool one that like I kind of blows my mind when it actually worked. Just like how many different steps it had to put together.
Yeah, so this one was a really nice one. Yeah. So I remember like waking up and reading some traces to report to triage that morning and finding this one where the trace starts like finding, well, it doesn't start like finding a JW signing token. Let's move to the next slide. I think we get like a little bit more context here. So at the beginning, it finds because we were given access to the Docker Hub file system. So in some cases, like very few of them, there were source code in there. In some other cases, it was the application binaries. In this case, it was a .NET application. So there were like a handful of DLL files. So it actually analyzed them. And it found some what looks like a JWT token. So it went like, okay, I found it. I'm going to use it to log into the application as an administrator, but it was expired. So it was like a moment of happiness that was short for Expo. But then he kept like pushing, right? And he was looking into the DLLs. And then at some point, it saw like there were like a few keywords here and there, like this S3 secret key, and then this symmetric security key. And then at some point, it started analyzing the DLLs, and it came up with something that looked like a base64 string down here. So he thought it could be a secret because of the order sequence of the words it was finding. And then it put together like in a matter of seconds, like a Python script to try different alternatives, different combinations, right? So first of all, it tried different secrets to sign the JSON Web Token. And then it also tried with different claims, including different key IDs, including the same secret, but also the one that it saw from the expired token. And then finally, it tried to get into reading the flag by using different paths, right? Because this was something that it saw in the traffic. It saw like there was this conversion storage file. So it thought about using path traversal to escape from the packet where files were expected to be converted into the file system. So it put together different payloads for path traversals, crafted its own JSON Web Token with admin privilege, and then basically just call it a day, right? So it was successful with one of the first attempts using the secret as this base64 string as the secret, the signing secret for signing the JSON Web Token, and then using the rest of the claims that it saw from the expired one, and then combining that with the path traversal, it was able to read the flag. So this was one of the moments that it's like, wow, this is incredible because it's not just finding this vulnerability or this other, it's combining them. It's it's kind of chaining different vulnerabilities in order to get to the goal, in this case, finding the flag, but also reporting like hard-coded credentials and path traversal in between.
Yeah, that's pretty cool. And it's a pretty diverse set of skills there too, right? Because they're doing a little bit of admittedly basic binary analysis at the beginning. There's some crypto mixed in there because it has to figure out how to get this hard-coded secret that it found used as a key for the JWT that it's creating. And then finally, on top of all of that, it has to figure out where this endpoint is that can access files and do a path traversal on it, right? So like I would want that person on my CTF team, I think.
Totally. Okay, let's move to, I think, the last one, and then we can maybe take some questions. So this is one we already blogged about. If you want to see the whole trace, it's already published. But we want to say it again because this was a good example of a SQL injection where we were using the time-based heuristic validator. And not just because of the successful validation of the vulnerability, but also to show you how XBOW can do things that maybe some like regular testing tools, like dynamic testing tools, may not be able to do, like adapt a payload. In this case, it found that, to begin with, it tried a SQL injection payload within a basic authentication header, which is something that is not maybe that normal to try if you are a pen tester. Well, you may think about it, but it may also be something that you do miss. And then in the process that you need to actually come up with the header, like a valid header, right? With the username, then the colon, and then the password. And then you have to base64 encode that, and then you have to send that. So that's something that you can do manually, of course, with Burp or any other proxy. But getting that automated by a kind of dynamic testing tool is not that easy. But for XBOW, it's not a problem because it's basically just thinking like a human will do. Like it understands completely the protocol, the basic authentication, what it's expected, what's the format, and how it should be encoded. So it comes like natural to XBOW, of course.
Nice. Yeah, and I think that that's something that is really interesting that again, if you had to do this without AI involved, you would have to think of every possible scenario. And web apps are just so diverse, and there's so many different ways that people decide to implement things that you're never going to catch all the different ways of encoding that someone might use and things like that. But once you have something that's a little bit intelligent, you can actually look at it, and it's not like it's hard to come up with something that base64 encodes the payload before sending it, but you have to think to do it in advance with, unless you have something like this LM-based approach. So maybe I do want to make sure we get to questions. So we'll I kind of go through this one in not very much detail at all. But basically, this was a more of a sort of logic vulnerability that it had found that was kind of cool. And we did this one again through this manual planting of canaries. Um, and what was kind of cool is, it really did dig through the source code to this project management system, and it figured out there was actually a lot more source code analysis than we can show here, because it had to trace it through about 5 different classes before it figured out how the visibility check on projects was implemented. And then it finally figures out that there's this one parameter that if you set that to true, it completely bypasses the visibility check and lets you see private projects. And in fact, here the command is authenticated, but we found out later actually that it also works even without a username and pass authentication. So that's a pretty bad bad one. But yeah, so maybe we can sort of just have the roadmap up here while we answer a few questions. I think uh, right now the state of AI is such that we can't totally rely on it, but we've got some things in the works that are going to be coming out pretty soon that make this a lot more reliable, that we think we can actually use to do fully automatic validation of vulnerabilities that traditionally scanners just haven't been able to find, like IDOR and business logic kinds of things. But yeah, let's do some questions.
Okay, let's look through the Q&A panel just to have time to submit new questions. There are a bunch of them to answer, so I don't know where to start. I don't know if you want to pick any particular one. Um,
Yeah, let's see. So I don't know, maybe there's some questions about kind of the architecture from early on. I guess I'm scrolling back a little bit. One that I thought was a pretty good question that I do think is useful to answer is about sort of sandboxing, because there are things
mhm.
that can try to trick an agent into doing stuff that it's not supposed to. And so, we actually solve this with sort of very traditional security techniques. The machine that we give it to do its attacks on is basically a throwaway Linux container that doesn't have access to sensitive things. So, it can execute commands by design, but we're trying to make sure that that doesn't have impact, right? Let's see what else. Some other good questions we've got in here. Do you have a favorite one you want answered, Alvaro?
I don't know. I was reading this one. Do you have an agent for each backtesting, like different agents for cross-site scripting, different for SQL injection, etc., different for validation? Yeah, we have different agents. Solvers are nudged or like guided into using specific prompts per vulnerability class, but also we have like free thinking agents that basically are not guided and still find vulnerabilities. So there's a mix of them that we are using at the moment.
So let's see what else we have in here. Okay.
There's another question about if we store like these payloads, for example, cross-site scripting, or and then we use some kind of rack like augmented. Sorry for it, but no, this is the payloads are dynamically built by XBOW. We are not using any specific database or rack for them. It's XBOW own security knowledge.
So there was a question about whether we can do white box testing too, and hopefully that's sort of answered by some of the examples that we gave. But we have been pretty impressed with what the agent can do with access to source code. It's not required, and we've been trying to make sure that it performs really well even without source code. But it is something where it can find some issues that it wouldn't otherwise, because it can actually look at the code, say, "Oh, okay, I can see." uh, I can search through for everywhere that it makes a external HTTP request, and that lets it look for SRF more effectively.
Yeah, there's another question about if Expo does white box testing. It does not in the sense of what you may understand as a white box testing and static analysis, but if you provide Expo with additional resources such as source code or documentation or even design document, that's some all information that Expo is gonna ingest and use on its own benefit and understanding of the application. And we've seen like many cases where Expo goes like try something like dynamic approach like black box testing, it fails, it gets like a 403, for example, then it goes, checks the code, understand what's going on, if there is a parameter that was expected, then goes back to the dynamic approach and then tests something new. Sometimes, like for example, in the case that we saw before, it's actually if you provide the source code, it's finding vulnerabilities in the source code and then validating them like dynamically. So it's not pure white box testing, but it's like a hybrid approach where if you provide it, it's gonna go back and forth between the source code and the browser and the attack machine.
Yeah, and actually, that's a great point about this ability to kind of combine these two, because that's something that, like, both I think in academia and out in industry, people have been really trying to do effectively for years and years, is being able to have one thing that both can understand the source code and can dynamically test what it finds there. So that's pretty cool that it actually exists now. Uh, so I did see one interesting question about um, basically how we make sure that we get comprehensive coverage. And I think that's a pretty interesting question because if you leave AI to its own devices, sometimes it has its own biases, its own things that it finds interesting, and so it'll prefer to kind of go deep on one particular part instead of checking comprehensively with everything. And so the way that we do this is actually with that coordinator component that we mentioned at the beginning on that giant architecture side. And that's keeping track of what attack surface there is in the app and what agents have been assigned to test which endpoints, right? And so we can ensure that someone has gone and looked at all the endpoints that we're able to discover, and we can try to do a very thorough job in the discovery process to make sure we find everything. The I know
Okay.
we're a bit over time, so if people have to start heading out, that's okay. We can stick around for maybe a couple more minutes and see if we get some fun questions here. Where are we?
Um,
I see a question that says, "Can you tell us the secret thing you haven't released yet?" And the answer is not yet. Um, so hopefully we'll be able to talk more about it once we actually get to releasing that.
Yeah, there are, I think, a couple of questions about how we make sure that Expo sticks to the scope of the test and doesn't get and start like browsing or attacking other domains. And that's easy if you remember the architecture. All the traffic originated by Expo goes through a proxy, so we can enforce some traffic rules like you can only hit these applications, and then we can actually tell, okay, I'm going to allow these domains for like maybe downloading resources like JavaScript, like CDN or something like that, or these other domains are going to get blocked. No, you can't touch them at all. Or for example, these are the only ones allowed for attacking them. So you can maybe download resources from a given list and then attack a different set of URLs. So this is really dynamic and flexible in the way that you can define what can be attacked and what cannot, but it's enforced in the proxy.
If I have anything to add to that, but that was a very, very complete answer. Yeah, so there's a couple questions about that I saw that were related to whether some of these like safety protections from LLM providers ever stop us from
Mhm.
doing effective testing. And this was something that actually surprised me when we started building this stuff. But they uh, basically we don't see rejections on safety grounds. Um, Part of that is that the kind of context that we set up for the agent to use is that we tell the individual agents that they're basically playing in a CTF competition, and that to win they exploit the vulnerability and get a CTF flag. And so it's possible that that is, that context is making it say, okay, this it's safe to use these sort of hacking techniques. Um, and the other thing that's actually pretty interesting about that is that it makes them try a lot. It makes both more persistent and try more creative things. Because if you tell someone that you're playing a game and that there's definitely an answer, then they're going to work much harder at finding it, and because they know that it's a solvable problem, right?
Okay, I don't know if we have more time to answer questions.
Yeah, I think it might be time to wrap it up. Thanks everyone for coming. This was crazy turnout. I was very happy to see everyone here, and I hope you had a great time learning about Expo.
Yeah, thank you very much. It was a pleasure.